I would like to introduce to you Rüdiger Kopp. Rüdiger Kopp will speak about the Elbphilharmonie in Hamburg, challenging project with a unique water mist protection approach. That's the title of his presentation. Rüdiger Kopp completed his studies of chemical engineering and safety engineering at the University of Dortmund as diploma engineer. He has been involved in the development, fire testing, approval and marketing of high pressure water mist systems for the last 24 years. Rüdiger works for Fogtec and is managing director for fixed water mist systems. He is a member of various international water mist guideline working groups, for example, NFPA 750 and ZEN 4972. He's also one of the founders of the International Water Mist Association. Rüdiger, please go ahead.
Thank you, Bettina, for the introduction, and good day to everyone. My presentation will be about a case study as well, the Elbphilharmonie in Hamburg, an Philharmonic Orchestra Hall. And this case study shall show how water mist can be implemented into a project in a quite innovative way. This was quite a challenging project in regard of fire protection, and we found a unique approach to this project with the water mist system. So the project is in the city of Hamburg in Germany, and the city of Hamburg, they aim to build one of the best concert halls in the world. They wanted to allocate to the river that flows along Hamburg, the Elbe, in a very outstanding location. This was a former warehouse in the harbor of Hamburg, a building which belongs to national heritage in the city, where they wanted to build a complete new landmark of the city. You see here two pictures from this building. It's a very extraordinary design by architects from Switzerland, Herzog and Moron, which combined the original brickstone building on the lower part with a glass kind of building, glass structures on the top, which represents the wave on the rivers when the wind is blowing. So quite interesting building. The whole project was funded by one major investor, but also by several donations by the citizens of Hamburg. Here you see a section through the building. The building is quite large. It has an overall floor area of 120,000 square meters and an overall height of 110 meters. So it's quite an extensive building, and it can be seen in Hamburg from all places. So it's a real landmark you have here. Into this building, the main aim was to build this special outstanding orchestra hall, Philharmonic Orchestra Hall, but it also houses a five-star hotels, restaurants, bars, but also residential apartments and also a parking area for the visitors of the area. The challenge in the project has been the concert hall as such. The rest of the building, a conventional sprinkler system has been planned for to cope with the requirements for active fire protection. And this conventional sprinkler system is protecting the hotels, the restaurants areas, and also the apartments. But for the concert hall it's such, it was very difficult to find the right solutions for fire protection, for an active firefighting system. That was a real challenge. Why is it so? You see here a photo of the area. This concert hall has a great height of 25 meters. So it was impossible to install a ceiling mounted system with a glass bulb operated nozzle of a conventional sprinkler system. This would never have worked. This would never have activated in the specific area where a potential fire would have started. So the alternative to use a deluge sprinkler system, of course, was no option, because you would have flooded the entire area and you would have created extreme damage by the water being discharged in such a system. So in the end, a conventional water-based technology was not a solution. In contrast, a gas firefighting system also could not be used, since it would have taken too long time for evacuation of the audience in the area. Then the fire would already have had a size that would have caused substantial damage to the orchestra hall. So this is also something that was no way forward. So this is where the architects, but also the fire consultant firm involved into the project has approached us as a manufacturer of high pressure water mist system to see whether we could develop a more innovative way of fire protection for these specific areas. And this has been done by looking at the fire risk, doing a fire risk assessment for the area. So if we have this height of 25 meters in the concert hall, still the fire load is concentrated close to the floor area by the seats into the area, but obviously also by the goods that the people would bring into such a concert, and by the instruments, of course, in the orchestra itself. So this is where the fire risk, since it's allocated to the floor, the idea was to not install a system in the ceiling of the area, but having more a floor-mounted system, developing the firefighting agent close to the area where a fire would start. And this is a complete innovative approach, which is not possible to be taken with conventional sprinkler technology, since these systems do not allow for such flexible approach into such an area. So water mist, fortunately, by the standards, allows this, since we anyway, as a manufacturer of the technology, have to prove the concept and the ability of water mist to fight such a fire in real full-scale fire tests. And I will come to that in the following slides. Now, since we have a floor-mounted system here, the system cannot be installed with as automatic system with glass pop operated nozzles. This would not have worked. So the approach was to install a system with open nozzle, a deluge system, which has to be activated by a separate fire detection system. And since the fire detection system would also be quite specific for the area, this also would have to be included in the evaluation process and also the firefighting analysis process into full-scale fire test. So the whole concept of how the system would be evaluated and tested has been developed by an external fire consultant firm. This is the German company HHP from Berlin, in conjunction with an independent fire consultant company who then inspected the fire test and also the final installation, which is the company DEKRA. The requirement for an active firefighting system was coming by legislation. So the local fire authority had to provide or had to ask for an active firefighting system for this area to safely evacuate the area and also to protect the entire building. So the water mist technology has been allocated to certain standards where the system has been designed on, and where the concept that has been developed has been based on. This is, on the one hand, the American standard for water mist technology, NFPA 750, but also the European standard. At that time, when the project was ongoing, it was called CEN TS 4972. Today, it's an EN standard called EN 4972, have been the basis for the design of the system. And the water mist technology and the related standards have a different approach than conventional sprinkler standards. They are very prescriptive. In the standards, it's exactly said how to protect individual type of risks, and the layout parameters of the system is also exactly specified. That's why an innovative concept with completely new approaches, for example, with floor-mounted nozzles, cannot be allocated to these conventional standards. Water mist has more opening grades there. There's an annex into the European standard, for example, or a reference in the NFPA 750, which allows to develop fire test protocols in conjunction with an independent expert company, with a fire consultant company, and to develop a fire protocol which then proves the ability of the water mist system to cope with certain fires that would be assessed to the type of risk. And these kind of full-scale fire tests which are conducted are then defining the design parameters, the layout parameters for the system. When conducting these fire tests, it's important that the fire load is exactly described, which would be expected in the type of risk, and also the arrangement of this fire load in the ambient, in the area. Ventilation conditions have to be taken into account, but also the way the system would be activated. And this is, in this particular case, the fire detection. So a real mock-up of the concert hall was built in a fire test hall. The fire test hall in this case had a size of 10 by 15 meter floor area, and into this a stage was built which represents the original kind of stage you would find in the concert hall here. So we have a test field of 6 meters by 6 meters. That means 6 rows of chairs with each 8 seats. This is arranged in different heights, so different steps between the seating areas were arranged to cope with the real scenario that you have in the Philharmonic orchestra hall. So in total, the test mock-up had a height of 2.4 meters. The test hall had a ceiling in 5.5 meters. However, this ceiling was open to the side, representing an area without any area limitation, because the hot fumes could flow away from the ceiling. So in the end, it is being conducted as if there would be no ceiling in the fire test. Ventilation was a concern here. Obviously, water mist with its small droplet sizes would possibly be influenced by the ventilation conditions into the concert hall. So this is why into the fire test, the original ventilation conditions were tested. So we had 6 ventilation openings, which each 60 cubic meter per hour, representing the real situation. Also, emergency lighting was installed, like you can see on the photo here. This was interesting for the fire brigade to see how visibility would be in the area once the system has been activated. And 2 different fire scenarios were defined. The most challenging was seen as a scenario if the fire is located between 4 nozzles. This is what was allocated in both fire scenarios tested. But then there was one at the higher level on this stage and one at the lower level, because this makes a difference in regard of positioning of the nozzles in the floor towards the fire, but mainly also in regard of the detection that we would have into the area. So all the tests were conducted with floor-mounted nozzles in this case, and as a detection system, 2 different type of system were tested. I will come to that on one of the next slides. So the fire load that we used here is a standardized fire load The seatings you see there, these are seats which are specified within the European standard for water mist technology for areas like office areas. But in this specific case, they have been modified to represent the original seat. So we had an additional seat coating onto this, which of course represents an additional fire load. The whole fire was started by a standardized fire load again, a paper cushion, according to DIN 5510-2, lying on top of the seat, being ignited, and then the fire could spread. The detection system would have to pick up this type of fire before the system has been activated. So different detection systems were tested, as already said. They were tested both for the lower as for the higher scenario, but the lower scenario turned out to be more difficult to be detected. A smoke aspirating system was tested, so the smoke extractor aspirating tube was placed above on each step, so actually at this position. And at the same position, also a linear heat detection system was positioned, and both were tested at the same time to see which system would bring the best results. So these were tested at the upper and lower position. And it turned out the linear heat detection system detected the fire very rapidly. And in addition, and this was very beneficial for the project, it was possible to localize the fire very precisely, very accurately. So based on this detection fire test, the fire consultant defined the pre-burn time, the time that the fire would freely develop before the active firefighting system, the water mist system, would be activated in the fire test, to 3 minutes. So that means that all fires in the detection test were detected within 1.5 minutes. So 100% safety margin was added to this. So then the fire tests were conducted. And even here, fire tests were conducted at the higher location and at the lower location in the stack. And it turned out for the water mist system that the higher scenario is the more challenging one. The fire tests were conducted between 4 nozzles, as I said. In addition, a special scenario was looked at if, for example, one of these floor-mounted nozzle would be blocked, would be disabled, for example, by some heavy obstacle lying on the nozzle, and therefore the nozzle not being able to contribute to the firefighting process. So this was also analyzed so that only 3 nozzles would take care of the fire in between these 4 nozzles. And the aim in general was to control and suppress the fires until manual intervention by the fire services would be possible, which of course on detection of the fire would be called in to come to the site. The fire test duration in this fire test, according to the standard, has been 10 minutes. And of course, after the fire test, the temperature development, but mainly also the fire damage was evaluated. And this is where all the tests have shown that temperature in the direct vicinity, but of course in the overall area, were very effectively controlled, were reduced. Thus, this made sure that a fire spread was very limited, of course, to the area where the fire was started, and just to the neighboring chairs. The fire did not propagate further, and this is exactly what we were aiming for. And it was also shown that the ventilation system had a very minor influence on the effectiveness of the water mist system. This ventilation system is floor mounted into the individual rows, but the distribution of water mist was hardly affected by that. And so the whole situation was controlled to the area where the fire was started. And this is exactly what the consultants were looking for and the fire authority was looking for. So the result were exactly what we needed to go ahead in the project. Now, based on the fire tests that were conducted, the whole orchestra hall or the whole philharmonic hall has been equipped with these floor-mounted nozzles. These floor-mounted nozzles, as you can see here, are mounted in the walking way in front of the seats. These seats are automatically flipping the seat up, so once the people in the area leave the space, we have a free way for the water mist nozzle to spray upwards. On top of the nozzle, a lid is placed, and this cover, this lid, makes sure that under standby conditions you don't even see the nozzle, and it's not influenced by people walking over the nozzle. So only in case of activation, this lid opens up and makes sure that the water mist is discharged from the floor area upwards. Now, the orchestra hall as such is quite large, and it would not be favorable for the client to activate all nozzles at the same time in the entire area. And this would also not be necessary, since the water mist system controls the spread of a fire very effectively. So the nozzles have to be zoned, or have been zoned into individual sections, and to make sure that if a fire starts just at the perimeters between different sections, 3 adjacent sections are activated at the same time. The pump capacity has been designed to get sufficient water flow for this individual area. So, and what has been very positive to integrate the system is also the very small bore pipe work. We talk about 12mm pipes here to connect the nozzle. So this was very favorable for the architects also to integrate the system into the concert hall as such. Now, what has been also a topic is how reliable these lids that you find on top of the nozzle would lift off and would make sure that the water mist will then discharge from the floor upwards. So this has been evaluated in specific tests, and has been demonstrated that the cover removes even if they would be obstructed by an object. So finally, in the hall, the water mist system have been integrated in the floor area. As you can see here, green marked in all the area. When the system activates, it will generate a water mist layer, which is about 3 meters high. But this is exactly what we are looking at, because, as I said, the fire load is close to the floor area and not in the gas volume above. So this is why this concept actually worked perfectly. And as I said, the individual nozzles have been grouped into sections. You see here, this would be a first section in the stage area, and then surrounding this, these would be the next one. And if you would have a fire in an intersecting point, for example, here, you would activate the 2 adjacent sections and the center section, so the 3 adjacent sections, to make sure that this kind of fire would be taken care of. So this type of concept has been quite interesting, and this has brought up a lot of interest of fire consultants and architects, also in other projects. So there are other concert halls or theaters we have in the city of Hamburg, which have approached us with similar type of fire challenges or design challenges for a firefighting system into their audience area. Here, for example, we transferred the concept which we used in the Elbphilharmonie into another project, the German theater in Hamburg. This is the largest spoken word theater in Germany, with around 1,200 seats. It's a listed building, a heritage building, which was opened in 1900. And this had to undergo a refurbishment, also in regard to fire protection. And this is where, again, water mist was seen as a very good solution for the theater hall area, which you see on the lower lower picture to protect the area, because the height again is quite elevated, and the ceiling mounted nozzles system would not have worked. And again here, the water mist nozzles were placed in the seating rows in between the seats, and made sure that we have a very effective system in case of a fire, to control the situation, to suppress a potential fire until the fire services approach the area. And this with minimal water usage, so with minimal water damage. A similar other project where this has been then transferred into other country is the Spanish Congress building in Madrid. The building as such, again, is a heritage building from 1850. This, due to the change in requirements in safety regulation, had to be equipped entirely with an active firefighting system. And water mist was seen, because of the heritage type style of the building, as a good solution for the entire building into offices, corridors, and public spaces. But again, there was a challenge here in the main Congress hall, which you see on the lower photo. And again, we had a challenge with the height here. And again, the concept that has been developed for the Elbphilharmonie has been adopted to this Congress hall, with a combination of floor-mounted nozzles with sidewall mounted nozzles. And this has been taken to other projects. One more I have here again in Madrid, the town hall Cibeles, also a heritage building, very large building, where all the floor areas have been protected with high pressure water mist. But the challenge again has been here the Congress Hall in the center, as you can see there, where again we have found a combination with floor-mounted nozzles and the protection of the adjacent area with ceiling-mounted nozzles. So from here, I want to come to the end of my presentation. You could see that the presented protection concept for concert halls and other spaces with this great height, water mist brings along a safe and architectural present solution for this environment, which is tested and evaluated in full-scale fire tests. The amount of water that we are using is very little, so that's why in case of an activation, the harm to the building and to the interior of the building is reduced to a minimum. The very high cooling effect of water mist technology provides safe escape routes for people who are still in the area, but also a safer environment for the fire services to approach to the area to carry out final measures. Especially for retrofit projects, the compact diameters of the system, both referring to the pumping unit, the water storage tanks, but also the piping is beneficial, so it can easily be retrofitted to an existing building, but also, of course, it can be used very efficiently for new buildings like we had in the Elbphilharmonie, where the architects were very happy about the small bore pipe size, which easily could be integrated into the floor area. What is important is that each project is looked at individually, that the concept we are offering is included to the overall fire safety concept of the building, and that an authority having jurisdiction finally evaluates by a third party, by a fire consultant, that the system is properly installed and that it is in line with the result from the full-scale fire tests. And this is where I conclude my presentation. Thank you very much for your attention.